All right, good day, everyone. What our focus today is going to be basically starting to sketch the graphs of polynomials. But to do this, we really have to kind of go through this whole idea of factoring. Okay, we have to be able to factor out a lot of different types of equations. Okay, so we're going to start the lesson off with talking about just some basic ideas, using our logic to help determine like what type of graph we're going to have. And at the same time, at the end of the lesson, we're going to go through a lot of just different types of factoring. You know, everything from like X method to grouping to like when you have a x to the fourth, how do you factor that? Problems like that, okay? So let's go ahead and get right into it. So the first thing we're going to talk about is basically if I'm given these two graphs shown here, am I able to tell which one is which, okay? And this is where we want to start understanding like what is each of these values telling me. So yesterday we talked about things like degree, turning points, certain values of that. We talked about leading coefficients, things that can all describe a graph to us, okay? What we want to do is start using those to actually answer questions like this. So like for number one, without a calculator, determine which polynomial function represents the graph, okay? So I want to figure out what graph of f of x, or what equation represents this graph of f of x, okay? Well, here's what I noticed. The very first thing I noticed is that my end behavior goes in two separate directions. I have a downwards on the left and an upwards on the right, okay? From what we talked about yesterday, this can only be detailed by one singular thing, okay? I need to have an odd degree function, okay? End behavior with opposite directions means I have an odd degree type of function. Well, when I look through A through F up there, there's only one odd degree function, and it's letter C. Okay, so just by knowing that small fact, I can pretty much assume that this has to be x to the fifth minus 4x squared plus 2. Or in other words, f of x has to be this equation. And when it asks what features is it used to help you find this graph, really all I just did was use the degree. Okay, because odd degree functions must be opposite and behavior, okay? Well, the same thing they're saying is that they want to use the same idea for the g of x graph, okay? Well, this one's not as easy because in the first one I could simply say like, okay, just based off end behavior, it's got to be odd. Well, in g of x, based off end behavior, it's got to be an even function. Well, 5 of the equations up there are even degree functions, okay? Where you think about it, you got an eighth, a fourth, a sixth, a fourth, a sixth, okay? So now I want to think about a couple more things. So first off, we know end behavior is going up, okay? The next thing I can say is that this has to be positive, right? If both of my end behaviors are going up, then that tells me this has to be a positive function. So automatically that can cancel out B, E, right off the bat there, okay? It's got to be a positive function. Next, I want to think about, okay, well, how many turning points do I have? Well, I have 1, 2, 3. Okay, remember, a turning point is basically a max or a min. So I have 3 total turning points. Well, we talked about yesterday how to find turning points. I take the degree and I subtract 1 from it. So this has to be a degree 4, which also means I could take away x to the 6th, x to the 8th, and all I'm left with is the value of d, which is x to the 4th minus 4.5x squared plus 2. So for g of x, it has to be this equation, x to the 4th minus 4.5x squared plus 2. Okay, that's got to represent my g of x. Now when I ask you what features did you use, I'm going through the whole process, okay? Well, it was even, okay? Both lines are pointing up, so I know it had to be an even function, okay? It was positive. Right, it was going upwards, so I knew it was being pointed upwards in a certain direction, so it couldn't have a negative leading coefficient. And last but not least, we had 3 turning points, which means it had to be a degree 4 function. Okay. So we want to go through that process of looking at all these different things to kind of help us out, because that's what's going to help describe the graph ultimately to us. Okay. Same could be said if I'm working the other direction, okay? Basically, it says, use what you know about end behavior, zeros of a function to sketch a small graph of each function. So let's start with an easy one. Let's say we have x plus 3 here, okay? Now, x plus 3 would be a very easy graph, right? You'd be up 3, and it would just create a line segment that basically looks like so. Let's put a dot there. All right, oops. Let me get my line up. Maybe not perfect, but just get the idea of it. That's the idea of what the graph would look like. Okay, and that's a linear function, but a linear function is also a polynomial. And I'll kind of describe why. X plus 3 is an odd degree function. X has a 1 degree power. Okay, I tell you this is a 1 degree power here, which means my end behavior should be on the left, I'm going down, on the right, I'm going up. Well, if you look at this, on the left, you're going down, on the right, you're going up. Okay, so based off my end behavior, I can describe that out. It's got to be positive because it's pointing upwards in the end. Okay, it's increasing at the end of this problem. So notice how all of that can be described within this problem. Same can be said for letter B, but I can get a lot more information from letter B now too. Okay, let's just go through a couple of things I can just pull out. First up, this has to be a degree 2. Okay, I can't look at it as a FOILed form. I want to look at it as if I actually distributed those two out. Okay, if I did x times x, that'd be an x squared function. Okay, we know it's going to be positive. I know I'm going to have x-intercepts at 5 and -5 because that's the two values of zeros. My y-intercept, if I did the two actual constants, 5 times -5, would have to be -25. Okay? So notice I can gather all this information from it. Okay, I can even go even farther than that. I know it's a degree 2 function. I know it's positive, so my end behavior just has to be pointing up. So I could literally make a short sketch of this by saying this is -5, 5. Let's say this is -25. And I know it's got to look something like this. Now, obviously, that's not the perfect graph, but the whole idea of this is that we can build sketches just based off quick, easy information from that problem. Okay? Notice how I was able to just take things out of it. I know it's a degree 2. I know it's positive. I know my x-intercepts. I can find my y-intercept, okay? All that information is given to you in these problems. We just have to be able to apply it and use all of it to actually start sketching these graphs out, okay? But all of this information is going to be important, okay? Like understanding this is kind of dealing with what we talked about yesterday. Today is really about what if I don't have a factored form? How do I get it there? Because truthfully, to get a lot of my information, I need this form. I need this form here. I need a factored form of the problem. Well, what we need to be able to do is we have to go through our factoring work, okay? Now, the first one they tell up here is one of the math tips is the quadratic formula, always an important one to remember. And they also talk about like difference of squares and things like that, difference of cubes and sum of cubes. Things are going to be important. But the ones that we're going to really focus on today is how do we factor by grouping, X method, everything like that, okay? So for example, if I look at letter A here, okay, if I do X method here, we'd have -20 on top, -1 on bottom. This would come out to be a -5 and a +4. If I wanted to solve that out, I would just have to do x minus 5, x plus 4, and then I get the two answers of x equals +5 and x equals -4, okay? So we have our first method. We can use the X method, right? The next method I could use, let's say if I just want to solve it out, okay? Granted, I can use a problem like this, like letter C. Letter C goes directly with the difference of squares. We have x squared. Okay, we have an x squared, and we have a 25. Both are perfect squares. So I could factor this out as the square root of 25 is 5, the square root of x squared is x. So this would come out to be 5 minus x, 5 plus x, okay? And that kind of feels like it's written backwards than what we've seen before, but it's also because look where the x squared is placed. Now it's considered to be the b function instead of the a function, okay? Next, like letter D, let's say we have x squared minus 5. Let's think about that. The 5 is not a perfect square, so how would I solve letter D? Well, once again, we're just going through a process of like, how would I actually solve these out? Well, if I want to get factored form, I need to find my zeros. To do this, I could take x squared minus 5, set it equal to 0 because now I don't have a specific factored form, and just solve. This becomes x squared equals 5. Take the square root. This becomes x equals positive negative 5. So my factored form of that would be x plus square root of 5, x minus square root of 5. Okay? So notice how really all I'm doing here is I'm showing you different ways of factoring, things that I'm hoping that we're feeling very comfortable with because we've done so much of it up to this point in our math careers. Okay? So the first thing we have is obviously the number A there, letter A there, we have factoring, X method. The second one, C, is just perfect squares, when you have two values that are a perfect square. And the last one, letter D, and at least in this example, is just solving it out. Okay? Well, let's go into a little bit more in depth. Let's just say we don't have specific values. Okay, so for example, like letter A, we have x to the fourth minus 81. Okay, so like when I look at that, I'm trying to think, well, how would I solve a problem like that out? Well, in this case, if I want to solve out this particular problem, or letter A or even letter C, let's just go ahead and solve it. Okay, so for example, if I want to solve letter A, let's just find our zeros, x to the fourth minus 81. I add the 81 over. This would become 81 equals x to the fourth. And now we take the fourth root to get x equals positive negative 3. Now, a lot of people are probably asking, like, okay, degree 4 means I should have 4 total roots. But I only have 2 here. I have a positive 3 and a negative 3. Well, no big deal. Understand that we're going to have 2 double roots for each of these problems. This is going to be x plus 3 squared times x minus 3 squared. Okay? So I can also solve problems out in this manner. Okay, I have so many different options to really, all I'm trying to do is find the zeros of the problem. You could do this using your factoring method. You could solve all these different possibilities. Okay? Now, even in like letter 8 here, okay, they even said just use the graphing calculator, which is something we've done already. We've talked about that earlier in the week, but it's just another possibility you can use to help solve these out. But the last type of factor I want to go through is the fundamental theorem of algebra. Okay, now this is kind of the idea of what would happen if I was given a function like this: 3x cubed minus 2x, 2x squared plus 12x minus 8. Like, how would I solve something like that? Or how would I even solve like letter D, where I'm given an x to the fourth? Okay. The key thing I want you to understand is that a lot of this kind of goes back to X method, a step that we've already done. Okay, so if I look at letter A here, when I read it, I see 4 different terms. Well, the beauty of this is if I have 4 terms, I have an even split. I can take these 2 values and split them up just like so. Okay? At this position here, at this point, what I'm allowed to do now is I can take out a GCF just like I would if I was doing regular factoring. Okay? Ooh, give me one second. I can't really see if that's a positive or negative 12. Positive 12, perfect. Keep that in. Okay? So now when I look at 3x cubed minus 2x squared, 3 and 2 have nothing in common, so I can't take out a GCF there. But x cubed and x squared do. I can take out an x squared from both those values. That would give me 3x minus 2. Now I have positive 12x minus 8, same thing, 12 and 8. They both have a 4 in common, so I can take out a positive 4. I can't take out an x because they don't have an x in common. So when I do that, that becomes 3x minus 2. So notice, when I simplify this, now I have the equation x squared plus 4, 3x minus 2 as my answer. If I want to get my zeros, I would solve each of those out. This one would become x equals, add the 2, divide the 3, they become 2 over 3. This one's a little bit tougher. If I were to actually solve this out, x squared plus 4 equals 0. That would give me x squared equals negative 4. And if you remember, anytime you take the square root of a negative value, you get imaginary answers. So this would become x equals positive negative 2i. Okay? And I can gather my zeros there. That one's called factoring by grouping. That's when you have 4 total terms you can factor out by grouping them together. Now in letter D, let's talk about what happens if you get an x to the 4th. How would you factor this out? Well, when I look at this problem, I see x method. Okay, I see a trinomial with really nothing too different built into it. So let's make our lives easier. The first thing I want to do is let's factor out a 4. Okay, let's factor a 4 out of this problem. That would give me x to the 4th plus 3x squared plus 2. Well, at that point, let's go ahead and do x method. Okay, you would have a 2 on top and it's 3 on bottom. Well, 2 times 1 would give me those values. So when I redraw my x method now, I just want to follow suit with what the equation's telling me. Okay, we talked about it before in x method. The first and last number will always stay the same. And the middle number is going to change based off the 2 values from your x. So this is 3x squared is going to split into a 2x squared and just a positive x squared. Okay? At this point, now I can group and simplify. This comes out to be x squared. I can take that out. X squared plus 2. I can take out a 1 here, and this would stay the same. And now I'm left with x squared plus 1 as an answer, and x squared plus 2. In which if I were to solve both of those, I would get 2 imaginary values as answers. I would get positive negative I and positive negative I square root of 2. Okay? So the main focus of this lesson is we have all these different types of factoring. Now, I know I went through this very quick. There's a purpose to that, okay? Because we're going to be seeing so many different types of it. There's no reason to spend more time on one over another, okay? Even in class tomorrow, we're going to be talking about all of these. We're going to be going through these problems. The key for you to understand is that we want to be able to move forward and be able to solve these out with all of our different factoring techniques. We have to be comfortable with every single factoring technique that we have, okay? Besides that, hopefully that you kind of took a lot of this in. Hopefully some of this was review, and hopefully some of it kind of brought back some certain ideas from past lessons. We'll be talking about this in class tomorrow, but you have a great day.